I welcome you in this career guidance program. Today we are having Dr. Ajay Nandgaonkar with us. Welcome, sir. Dr. Ajay is basically a physicist. He has completed his PhD from Pune University and Tata Institute of Fundamental Research. After that, for some period, he was in teaching field. He has worked in various areas in physics like superconductivity and many others. He has also worked on the world's biggest supercomputer, commercial supercomputer. And he has worked on many projects. So today we are really very fortunate to have Ajay sir with us. Sir, I would like to ask, when we say research, there is a specific idea in students' mind. Research means big, huge laboratories and scientists wearing aprons and rushing here and there. So can you please explain us what exactly research means?
What is research? So, the simplest form of research is satisfying your curiosity and working hard to figure out a question whose answer you don't know. That is the simplest way to explain what research is. But what you said about labs, so there are these large labs. So if you're doing experimental research, um, these large labs, you will be wearing aprons and going around and trying to do experiments. So let me explain the bifurcation of pure sciences or research in general. There are two kinds of research. One is fundamental research, and the other is applied research. So fundamental research is questions like what is the structure of matter, what is stability of matter, how old is this universe, what is this universe made of, or uh, what is life, what is the structure of the DNA, these kinds of questions, which are basically quest to understand different aspects of nature. That is fundamental research. Another applied research, which is also equally big and equally interesting and equally important, is applying some of these ideas of science and engineering to solving problems which are relevant to us and coming up with new solutions there. So, for example, putting a man on moon is when they did it for the first time, they had never done it before. So, several new things had to be figured out and tried out, and that was a mission. So, that is sort of all the research which went into that was with a goal-driven research, where want to go and achieve a goal. So, if I'm in a pharmaceutical company, I want to find a cure on a particular disorder. Then I'm going to focus all my research into figuring out what is that molecule that is going to take care of this disorder. That is applied research. So this is the broad classification of research, but it's essentially going after a particular question and trying to figure out the answer to that.
You have been working in the field of physics. If students want to go for research, what are the sub-branches? Because physics itself is a subject which is related to almost all subjects in this world. But still there are sub-branches of this subject. So will you please explain those?
Research per se in physics happens at different levels, and I'll explain what I mean by levels. Let's look at length scales. So let's say that I'm looking at a length scale which is, I want to ask a question as to what is inside an atom or what is inside. So atom we know is made of protons and neutrons and electrons. Then the nucleus is made of neutrons. So I go inside the neutron. What is the neutron made of? So where does this end? So that is an area called high energy physics or particle physics. So we all know that recently the Higgs boson was found at CERN. So particle physics is an area where you want to figure out fundamental particles in the universe. So that is one. So you can do experiments as well as theory. You can calculate and predict, and then those are verified by experiments. So that is one level of research. So if I now come outside and I take a few atoms and I ask, how do they interact with each other? What are their properties? Then that is the buzzword of today, which is nanotechnology, nanoscience. So which is basically figuring out properties of materials. Can I make new materials? So a generic area of this is called condensed matter physics, where you ask questions about different materials, how their properties change, and how uh, can I modify these properties. That is one. Then if I increase the length scale slightly more, I want to ask a question like, can I predict a tsunami? How does a tsunami propagate from, say, Australia to Indonesia? Now, if I want to calculate that, then the laws of physics are slightly different, and that is a different scale of physics, which is called ocean physics. Then geophysics, where you want to understand the structure of Earth. This will be, for example, relevant for all oil and gas companies. They employ geophysicists, so that you can figure out where to drill and get oil, or curiosity-driven questions like what is the Earth made of, how deep is it, what is the chemical composition of the crust, such questions. So that is geophysics. And if I then take the length scale to a large length scale, then questions about the solar system, our galaxy, systems of galaxies, and globular clusters. So that's astronomy and astrophysics, and cosmology. So cosmology that deals with the origin of the universe. Uh, so actually, from the smallest to the largest, that's essentially the scale of physics.
Very true. The high school student decides to enter this field, then which pathway he should take of education, and how can he get further training? Which institutes are there in India or abroad which can give such type of education?
So 9th standard student basically has to, if you're a student who is very clear at 8th or 9th standard that you want to become a researcher, which is fantastic. I mean, most students don't have that clarity. But if you have that, then you would basically try to do more experiments in what you learn in your class, and ask more detailed questions about it.
Right.
That is at the basic level. But your question is broader. You're saying what training and how to go about it. So if you want to do research in pure sciences, these days those boundaries between physics, chemistry, biology are sort of mixing up. So if you look at, say, for example, an institute like National Center for Biological Sciences, which you can do a PhD in microbiology, even if you have a degree in chemistry, you can join their program. So the idea is to do a science degree. So you could be an engineer, you could do science, or you could do medicine, you could do BSc, BSc or integrated MSc from a range of institutes in India, and then get into a PhD program in a good institute. So I will talk about the institutes later.
Okay.
But the idea is that your basic training in terms of science and technology can be done in any of these courses. So you don't have to decide in 9 standards that you want to be a researcher. And if you join an engineering course and you find some aspect of physics interesting, after your course is over, you can always get into it.
It is it rarely happens that a student decides at the age when he is in 9th standard, I want to become a researcher. But if someone has that urge to become a scientist, then how shall he groom himself?
Clear that you want to become a scientist, then the first and the foremost task is to basically learn and know as much about what is happening in science as possible. Now, there are many ways of doing this. One is, for example, there is this beautiful exploratory in Pune, which is started by Professor Mide, where you can go and do experiments with your own hands. Try and set up a lab at home, try and set up a lab in your bathroom, and figure out things that you don't understand. So that is a beginning. But you can do that in a more structured way in a place like an exploratory. Then there are science popularization programs of institutes like IUCA, which is the Inter-University Center for Astronomy and Astrophysics in Pune. So they will run several science popularization programs. You can be a part of those. And there you get to meet scientists, so you can ask questions. And I think that is the most important bit in training yourself for science, is that if you think that there is a question that you have, and if you think that it's a stupid question, try and ask it to about 15 people around you. It's very likely that they will not know the answer, which will tell you that this is not a stupid question. So don't stop asking questions and pursue your questions to uh, till you find the answer that you're seeking, and understand new things, and never be convinced that you've understood everything. I think that's important, and if you remember this, then you are already a scientist.
Have said is really very, very important, that once you get your answer, you don't be satisfied and don't be convinced that you have understood everything. I would like to ask one more question. Apart from research, what are other career opportunities which are related to this field, that is field of physics?
Let us assume that you thought that you want to pursue pure sciences, and you choose to do your BSc or MSc, and then you say that no, I don't want to get into research. So well, that is a fair thing to say, because it's good that you know that you don't want to do that. But now, in today's world, there are lots of opportunities in private companies, like for example TCS. I work with TCS there. We would employ you for your analytical skills, because what you're trained in is essentially a systematic way of thinking about a problem, and you've gained some ability to do some calculations which are very useful in solving the problem. You can work in a pharma company, you can work in an IT company, you can even work for a bank, because these days uh, there is this whole new thing about financial engineering. Some tools of those you learn today when you do a master's in physics. So this is one set of one aspects of getting a corporate job or getting an industrial job. That is, in modern times, this has happened very well in this century. I can say from 2000, the job opportunities for physicists as masters has grown up very significantly. And there are other aspects of it. For example, you could do cephalogy, or you could do you could do IAS with physics as a major. So by doing masters in physics, I don't think any doors are closed.
It is really such a subject which is connected to almost all subjects, as we have said. Sir, do you think that as compared to other professions like doctor, engineer, this field is not explored by many students? And if it is so, can you please tell us why should students come in this field?
Yes, but I think so. If you look at the total number of students going for BE computers versus BSc or MSc and PhD, then of course the number is very small. And I think it's not necessarily their own choice, but it's also their parents' choice. Their parents sort of push them into doing engineering and medical because the parents want them to be settled early, or whatever that means. But I know engineers or doctors who have interest in pure sciences like physics and chemistry and biology. And after their engineering degrees, they have pursued physics PhDs, or or PhD in molecular biology, or neurosciences. So even if you've done a professional degree, and if you at the end of that degree feel that mechanical engineering, I don't want to probably work in a industrial environment, and that doesn't excite me. But what excites me is physics, because you also learn a lot of physics and chemistry during your engineering. Then what I would say is that you should listen to your mind and listen to your heart and sort of follow it up. So such possibilities were not existent before, but they are now. So if you think that you can't say when you will realize that you want to become a researcher or a scientist. You can get that idea at the standard when you are in 9th or 10th or 8th, or you can get that idea at the end of your bachelor's or at the end of master's. Whenever you get that urge, I would say that do not suppress it and just follow your heart. Yeah.
So thank you so much for being with us. I'm sure students will be definitely motivated by this guidance, and they will be encouraged also to take this field, to choose this field. So thanks again for being with us and sharing such important information.
It has been a pleasure. Thank you very much.